Okay. Hey, everyone. Very excited to be here to host our next event, which is an AI faculty panel with faculty from some of the top AI groups in the world. So we've heard a lot from folks in business, from customers about AI, but I also want us to hear a little bit about what's happening in AI research and what these researchers who are leading the way are excited about next. So I'm really excited to introduce three members of the panel today. We have Mike Carbin, who's a professor at MIT and also a co-founder of MosaicML. When we started the panel, it was before anything was even happening with MosaicML and Databricks, so awesome to have him here. We also have Don Song from UC Berkeley, who's an expert in AI as well as security, and Daniela, who is the director of MIT CSAIL, arguably the birthplace of AI research in general. So welcome them all to the stage with me. Yeah. Yeah. Wow. And huge props for Daniela for coming here despite Crutchers being injured. She's amazing. So, we didn't even know about it until very recently. So yeah. So welcome everyone. So let's start with some introductions. If you can just each tell us, kind of what you work on, what have you been doing, recently that you're excited about in AI research to give the audience a sense of it. And maybe Mike, you can begin.
Oh yeah, sure. So I'm here with my two hats on. So my academic hat, where I've been doing research for about 15 years, and of course my MosaicML hat, where I'm a founding advisor and having a great time doing work there as well. And of course, potentially our plans to join the Databricks family shortly. And so if you look back to the history of what I've done, where I come from computer systems. And particularly my entire interest has always been in how do I make computers go fast? How do I make them more efficient? And I do a lot of work as well in the programming languages and compilation space. So how do we look at the structure and organization of programs, again, to make them faster and more efficient? And perhaps for this audience out here in the data space and the database space, thinking about things like query optimizers, that's where I spend a lot of my time. But how did I get into AI? Well, in some of the work that I've done with my students over the past several years, what we've done is we looked at the structure and organizations of neural networks themselves to identify there's parts that perhaps don't matter. So we can take these very large models, turn them into much smaller models, perhaps an order of magnitude smaller, but still train just as well and still give you good, amazing results. And over at MosaicML, these perspectives towards efficiency is what we've been driving based on those insights of how can we take these large models and make them much more accessible for you and everyone else that's out there, right? These models aren't only in the hands of the largest organizations, they can be in everyone's hands.
Great, yeah. Don?
Great, yes. So I'm a professor in computer science at UC Berkeley, and also have a startup working at the intersection of AI security and decentralization as well. So there are so many exciting areas that we have been working in the areas related to AI. So here I'll just talk briefly about the areas at the intersection of AI and security. So given all the amazing advancements of AI capabilities, LLMs, and so on, so of course, one application domain that's really exciting is in the security domain. All these advancements in LLMs and so on can really help a lot in the security application domain. For example, some of our recent work showed that by even just using ChatGPT and these large language models, actually it can really help significantly improve, for example, security audits of applications. For example, we were able to show that it can significantly improve the manual audit efforts for security audits for smart contracts. And also we showed that by using these large language models trained on, for example, blockchain transactions and their execution traces, we can identify anomalous and malicious transactions. And for a broad spectrum of different applications that we examined, these trained models can actually rank attack transactions in the real world to be actually the most anomalous transactions for over dozens of different real-world applications. And these attack transactions actually have caused close to $300 million worth of damage in the real world. So this is just another example illustrating the power of these new large language models and the AI capabilities. And on the other hand, of course, these type of capabilities also pose a lot of challenges. That's also something that we have been studying. For example, showing that these large language models, they have big privacy leakage problems. And also some of our recent work in collaboration with Meta has been on how we can enable privacy-preserving AI model fairness assessments. And this actually is the first of its kind, large-scale real-world rollout that's been rolled out to Instagram users to help for the first time in a privacy-preserving way to assess the fairness of AI models that's actually being used in the real world. So these are just some examples of exciting areas that we've been working in.
Very cool. And Daniela?
Well, so I'm also here with multiple hats. I'm a professor at MIT. I run CSAIL. My former students and I have a number of companies in the space of AI, and it's just such an extraordinary moment for our field, and in particular for AI. Now, at MIT, what I'm most interested in is really asking some foundational questions about what AI can achieve. And so if we think about the fact that the majority of the successes we hear about today are due to decades-old ideas that are now empowered by data and computation, it's kind of natural to ask, what else is there? Because if we do not come up with new ideas, in time, everyone will be doing the same thing, and the contributions will be increasingly incremental. And so I'm super excited about a new approach to machine learning, which we call liquid networks. It's a compact approach to machine learning it's a kind of a continuous time approach for applications that have time series data. Liquid networks are compact, provably causal, and they have very nice generalization properties when trained in one environment and applied in a different environment with really huge distribution shifts. And so, the world is trying to make networks bigger and bigger. I want to make them smaller. And so to give you a sense of what you can do with liquid networks, in our work, we do a lot of edge device and robot applications. And so, for instance, if you want to get a robot car to stay in lane and steer, it takes about 100,000 deep neural networks to get good behavior. And it only takes about 19 of our liquid networks. And so if you have a solution that involves only on the order of a couple of nodes, or maybe on the order of tens of nodes, you can then extract decision trees to explain how that system makes decisions. And in doing so, you can begin to address safety-critical applications where knowing how the model reaches decisions is very important.
That's super cool. Yeah, I do think now that we've gotten neural networks with gradient descent working, people will discover so many other ways of doing this kind of computing and in a much more controllable way. So super exciting to hear about that. So one question I had for all of you is, as researchers, you see a lot of the emerging ideas in AI, and here we have an audience with many practitioners who are, building things every day. So what's an idea or an approach you think is coming up in UI that, in AI that is looking promising and that you think practitioners need to know more about, that they aren't paying enough attention to? So curious what each of you think about that, if whoever wants to, yeah.
The eyes are on me, all right. Let's see, so we're at a big data conference. I guess I actually want to say small data. And so what I mean by that is there have been some interesting results, some things that we've been working on, some things that other people have been working on. And a highlight I think you can look at from the past couple weeks, it's maybe a month old at this point, there's this paper, Textbooks are all you need. Now, it's important if you see a paper that's out there in academia, sometimes it's less about the result and more about the idea, as we're talking about here. But what they were trying to do, they wanted to go out and build a code model, like a code generation model, sort of like what you were seeing yesterday in the Lakehouse IQ example, the Lakehouse Q demo, where large language models are going to generate code. And the typical way that you're going to do that now is you can find as much data as you possibly can. Scrape the internet, Stack Overflow, all these data sets that are large and pretty dirty in some ways. Throw them into a model, and this thing will amazingly generate code. Really great. But these models are large, right? We're looking at ChatGPT. In that, at least in the 3.5 ChatGPT with GPT 3.5 in that 150, 175 billion parameter range. These are large, these are massive, right? And we think these models are perhaps out of the reach of many. But in this paper, what they did is they find, again, small data. If you do a very good job of trying to curate your data, you can find these opportunities to process on less data, orders of magnitude less data, and with orders of magnitude smaller model. So they had a 1.3 billion parameter model that was besting some of the best models that are out there in the 15 billion parameter range, and even exceeding, at least in their domain evaluation, the results that you're getting out of ChatGPT, driven by GPT 3.5. And so I think that's the future, this future of focus, right? ChatGPT is absolutely amazing. It knows everything in all these different domains. But when you can focus on your particular domain and your use case, I think they're really good opportunities for building these models and building these models yourself at a scale that's accessible to you. And so that's the direction I see, because I know everybody's thinking about ChatGPT. But these new coming directions with these smaller models, I think, are very promising.
Very cool. Yeah.
I think for practitioners in general, practitioners are really excited about these new capabilities and want to use them in different applications. And so on one hand, it's really exciting to see all the great progress and cool things you can do about it. But on the other hand, I think one thing that usually practitioners maybe don't think enough about, that's the thing that I wanted to emphasize here, is that often because these services are exposed to the general users and so on, like you have to think about how these services may be misused, for example. These AI models, with our work and with other researchers' work in the community, these models have a lot of security, privacy challenges and issues. And they can be easily, it's called jailbreak, and also they can be fooled in giving wrong answers. And also, as practitioners use models out there, actually, there has been, our work and others' work have shown you can very easily implant, for example, these, we call them backdoors or trojans into these models. That's very, very stealthy. You don't even know that they're there, but actually, then the models can be triggered under specific conditions to misbehave. So this is just the tip of the iceberg. There are lots and lots of these different types of security, privacy, and other types of trustworthiness issues with these AI models and how they can be properly used in the application domain in a responsible way. And I think one of the really big challenges actually for practitioners for deploying these models is how do you know when the models are actually ready to be deployed? How even to measure how the model essentially behaves, or what are the metrics for measuring the trustworthiness and the different aspects of the model. So one of our recent work with my wonderful many collaborators is called Decoding Trust. You can actually go to the website decodingtrust.github.io to look at more details. So this is the first really comprehensive, systematic evaluation framework that covers a full broad spectrum of different aspects, different metrics in the trustworthiness of AI models. And this is only just the first step. We hope that this, as an open source framework, we can encourage the community to come together to further develop this, to really help practitioners to know better how their models are doing, besides just the performance perspective, but actually more in this broad trustworthiness perspective, to really know when the model actually is ready to be deployed. If not, what are the issues and so on.
Very cool. Yeah.
So we can talk for a long time about the excitement of the work in academia, because despite the fact that we have such extraordinary potential from AI, there are a lot of problems that need to be addressed in order to make AI safe and trustworthy and environmentally okay and easy to deploy. I guess Don was talking about how do you know when the model is ready. Thinking about rigorous approaches to testing testing and evaluation is super important. Thinking about how we build trust in how we use these, how we use AI is super important. But if I can pop up at one level, I would say that when I think about how AI is used today, there are basically three categories of AI solutions. We have AI solutions that are primarily about pattern recognition. And this is where deep learning and variance kind of fall. And then there are AI solutions that are primarily about deciding what to do. And this is the kind of the body of work around reinforcement learning. And then there is the group of AI solutions that are all about generating new things. And this is the generative AI space, which includes tools like GPT. And in each of these areas, the academia is actually working to better understand what kind of solutions we get to increase the representation. In other words, what can the models represent and recognize, and also to really understand the properties. And I will tell you that in each of these three categories, we have issues. We have issues around data because they all require a lot of data. And that means that the computation is huge. That also means that there is a large environmental footprint. I mean, did you know that deploying a very small, for today's standards, model today releases 626,000 pounds of carbon dioxide in the atmosphere? This is equivalent to the lifetime emissions of 5 cars. So as we think about deploying AI in the future, it's important to keep these numbers in mind because we want tools that support humanity but also the planet. So we have to deal with data, we have to deal with computation, we also have to understand the black box and ensure trust and privacy in our solutions. And so the good news is that the academia is working on all these problems. And next year, when we come together at this meeting, we can report to you on more achievements.
Makes sense. Cool. Yeah, I think we have time for a couple more questions. So so let me try to think about some of the more interesting ones. So okay, so one question I have for everyone that I think is on everyone's minds here is, what do you think about AI becoming sort of democratized or commoditized? So like on the one hand, things like computer vision, you can run pretty much anything that's state-of-the-art on your mobile phone. On the other hand, we've got large language models, which are extremely large, and it seems making them larger makes them even better. What do you think about the technology trends? Will this be something that kind of everyone that will get a lot cheaper, that everyone can do, or what are sort of the pro and counter arguments for that?
Yeah. I've already said it.
Yes, we don't. You believe.
I can just say it over and over again. Yeah, I think these are the trends that are taking over. And when we talk about democratize, I still feel like I want to break that into two different categories. One is, we see ChatGPT, and it's absolutely amazing. Again, like I said, it knows literature and the arts, sports, pop culture, right? Anything that you can think of, right? I mean, it's truly, truly revolutionary, I have to say, when I first sat down and started using it. I hadn't expected to see these types of capabilities, particularly in the interactive code generation, sort of getting back to my domain, perhaps in my lifetime. Truly amazing. I think in that space, we're already seeing democratization in the sense of increased competition, right? I mean, Bard, Claude, Pi from Inflection, the results that we're putting out at Mosaic. There's a hot race, right? The economics are there to bring down the costs of those models. Now, I think there's this other direction as well on, can you build these things yourself, right? Perhaps it's great that there are these closed models that are out there that you have access to, but could you build this yourself? And I think the trends are positive there as well. So going back to what I had said before, this textbooks are all you need result. If you can focus, right, again, so ChatGPT can do everything, but if you're building a biomedical model, do you need your model to give you sports statistics, right? Or talk about Taylor Swift? No, right? But with ChatGPT, you're paying for all of that, right? You're paying in terms of amount of data. This model needs to be trained on all of this data. You're paying in terms of the model size. The more data, the more recall you need over a larger knowledge base, the larger the model needs to be able to do that effectively. So if you can focus, there's opportunity there, right? And textbooks are all you need. There's an example there in some work that we've done at Mosaic. We actually did this in the biomedical setting where we trained a small, by, again, relative measures, 3 billion parameter model on PubMed, which is this huge biomedical corpus that's out there, biomedical papers, scientific papers. And then fine-tune this to actually respond to questions on the USMLE, so the US Medical Licensing Exam. And we set state-of-the-art results. Of course, that was back in December, and we were able to beat models that were 120 billion parameters at the time because we were able to focus. Right? So for me, it's about focus. And I think those trends are in the favor of everyone sitting in this room where you've got really interesting data, and it's just about focus being on that data and building models around that space.
I can jump in
Go
if
ahead.
you. So I think that there's already democratization. Like everyone uses ChatGPT, no matter what aspect in work and also in life. And the tool is extraordinary, but the concern is that people don't actually understand how it works. And so, so this actually causes a lot of problems with how the tool is used and how people respond to the fact that now we have these extraordinary tools. And I would say that it's important for the public to really understand what tools we put in their hands. So communicating to the public and educating the public is important. And that begins with highlighting that indeed, the tools we have today are democratizing our access to information. They're kind of giving a microscope into the digital universe. But this microscope is going to make mistakes. And so it's not about, so using the tools is not about replacing activities, but about augmenting the human with some extraordinary new capabilities. I like to tell people that they should think about using an AI tool sort of like they think about an assistant. The assistant runs around, looks for patterns, brings interesting data for the decision maker to act on. The human really still has to stay in charge. The other thing I will say that this democratization is causing a lot of fear in the population, fear that a lot will be replaced by machines, and this is just not the case. And so we have to be careful with how we excite people about being empowered and augmented with new tools rather than being replaced by these tools.
Cool. And yeah, one more quick fire round because we're running out of time. So just quick answer. Obviously, everyone's very excited about LLMs now, but there are so many other types of data, so many other types of applications, interactions we can apply AI on. What do you each think is going to be the next area to get a ChatGPT-like moment?
That's great.
Liquid networks.
Okay. Very general, yeah.
Area. Oh no, I'm still
He
processing ChatGPT.
He said short.
Done.
Oh, I mean, also following up a little bit to the previous question, I do think, this democratization, there are many different aspects to democratization,
You have
right?
good negative results in this space.
Yeah, right. So, like this, you can look at it's also open versus closed source, and also ultimately, like we talk about this personal assistant that helps individuals, but who actually controls these personal assistant? Whether we want to just have the big tech companies have closed source models to control that, or we want to have open source models where actually individuals really can have these kind of personal assistants that's actually under their control and really try to act in their best interests. And following what earlier said, essentially, so recently we had some results talking about the challenges for building open versus closed source models. Yep. We had this paper on the false promise of imitating proprietary models.
Imitation is not enough, yeah.
Right, so it's not so simple. You actually really have to do the hard work to improve the performance and of the base model and so on. So there's a lot of challenges, and how can the open source community to come together to make that right, to really try to close the gap.
Yeah, so the training process, makes sense, Cool.
Michael?
I think I just want to say multimodal, right? So
Multimodal, yeah.
Multimodal.
Multimodal.
I'm required
Yeah.
as a programming languages person to say code generation, but just multimodal. So I think
Yeah.
we're just in this age where we suddenly have the capability to have multimodal interactions with computers, and the fact that that's going to bring so much new capabilities, so many people who could previously only access computation via programming, right? And perhaps those people were excluded. I think that's just the future.
Yeah.
More computation for everyone.
So I do want to jump in because I only had 2 words. And I will say that I agree with everything my wonderful colleagues have said, but I think we also need to understand what's happening in the box. And so aiming towards causal models is important.
Yeah.
And the other thing that's important is to get a better understanding of what's happening inside the box, because ultimately we will get to the point where we will need certification, or we will need some kind of deployment guarantees when we put AI in service, especially of safety critical applications.
Yeah. Very cool. Well, thanks so much, everyone. Really awesome to have you here. Yeah.
Great, thank you.